And welcome to the lecture on programming, data science, data analysis, and deep learning in Python. Last week we have introduced functions, and I can really recommend you. I think functions are one of the most important tools in programming, and I really recommend you to use functions as much as you can. As opposed to global variables. So I recommend you not to use as few global variables as you can, and in particular to avoid accessing global variables from inside functions. This really messes up your code over time. Are there any questions for the lecture to the content that we've covered so far? Okay, then I will proceed with functions. And we saw that it's not straightforward to access, especially to write to global variables from inside functions. So for example, if we have a global variable x, which is 3, and then we have a function def x to 5, where we try to set x to 5. Does anybody remember what will happen? Yes?
Nothing. X will, depending on from where we access the variable, x will be 3 or 5.
Yeah, but if we, okay, so let's write, so let's do print before. X. Then let's call x to 5. And then let's print after. So what will happen in this case?
It's still going to be 3 both times.
And why? Why is that?
Because x is a global variable and we cannot access it from inside the function.
Yeah, exactly. So this x, if we set x, if we say x equals 5 inside the function, what Python will do, it will create a new variable, a new local variable x inside the scope of this function, and it will assign the value 5 to that local variable, and it will not change the global variable x here. So if we go back to the to our favorite diagram, if we have the references here and the objects here. Then we have a global variable x, which points to the object 3. Oh, sorry. Then, as soon as we go here and we call that function, Python will create a new local variable scope for us. So these are the local variables for x to 5. And here, at this point, when we say x equals 5, Python will create a new local variable, x, inside this local scope. And Python doesn't really care that this variable has the same name as this global variable. They are completely different variables, right? There's one local variable in the local scope, and Python, it doesn't really matter for Python that there's another variable named x in the global scope. And we assign this the value 5. So that we do that doesn't influence at all what happens to the global variable x. And then when the function x to 5 is finished, then this entire local scope gets deleted, and in the global scope, nothing has changed. Okay, so it should be before 3, and after it should also be 3. Now, if we try something slightly differently, if we say a equals 3, and then we define a function x to 5 that takes a parameter x, and now we say x equals 5, and then we say x to 5 of a. Can anybody say, then let's print print a. What will happen in this case? Yes?
Yeah, A will still be a 3 because the x is still a local variable, which should just be changed to a pipe inside the function and not outside of it.
Yeah, it doesn't change a, right? So let's draw our favorite diagram for this situation. So before we call the function, we say we have a global variable a, that is 3. We have no local scope. Then we call x to 5. In the moment that we call x to 5, this local scope gets created. And we see that x to 5 takes a parameter x. So a new local parameter, a new local variable x gets created, which then gets assigned the same value, the same object that a points to. Because at this position here, we say we want to assign to this local variable x the same object that this global variable a points to. So now x points to this 3. And then we say now x equals 5. So what we say now that now x shouldn't point anymore to the 3, but x should point to the 5. And then the function finishes. So all of this here gets deleted, and a still points to the 3. So we didn't change at all what a points to. So a still points to 3. Now let's do a slight variation of that. Let's say a is now a list which has one element, which is the number 3. And we define a function x element to 5 with a parameter x. Now, inside the function, we set the zeroth element of the list x to 5. And then we say x lm to 5 of a. And we print a. I hope that looks nice. What will happen in this situation? Yes? Yeah. So let's draw our favorite diagram. So before we call the function, we have a global variable a that points to a list. And the list has one element which points to the 3. And a points to that list. Now we call the function x element to 5. In that moment, Python creates a new local scope for us with a variable x. And x points to the same object that a points to. So now x points to this list. Now inside the function, we follow the variable x. We go to this list. We take the zeroth element of that list, which is the 3. We take the zeroth element and we make that point to a 5. So we remove this reference and we change it like this. And then the function finishes. The local variable scope gets deleted. And a still points to the same list. The list that a points to hasn't changed, but the content of the list has changed, right? So the 0th element of that list now points to the 5. Who understood that? Who found that confusing? Okay. So the point is that this green arrow has not changed, right? So A still points to the same object. We have just changed the object that A points to. Let's look at that. So A is now a list with one element, and that single element is a 5. So the difference really is that in this case up here, we just make the variable x point to a different object, right? And that doesn't influence the object that A points to. Whereas in this case, x still points to the same object. It's just we change the content of the object. We change the object itself. Yes.
So, as a rule of thumb, it's like that you don't create a new list, as would be the case for creating a new variable inside a function.
So yeah, inside this function, you never create a copy of the object that you get. You assign to this local variable x, you assign the same object that this variable here points to. Right? So the object that A points to will be assigned to the variable x. And you don't create a separate copy of that object. Right? So you don't, yeah.
But that would be the case in like the first
No.
case.
No. In this case, we have a local variable x. We assign that variable x the same object that A points to, which is the 3, but the 3 doesn't get copied. There's only one 3. And then we say that now we don't change the 3. We change the object that x points to. X now points to a different object, but we don't change the 3 itself. So we don't make the 3 into a 5 or something. We just say that x now points to a different object, and it doesn't point to this 3 anymore. Maybe I can draw the both situations next to each other. Okay, so in the first case, before the function, we have a global variable A, which points to an object, and that object is the 3. Now we call the function, and in the moment that we call the function, here we have x to 5. We create this local scope with this local variable x, and x now points to the same object. So we never create a copy of this object. It just points to exactly the same object. And the same is true so basically the same thing happens in both situations. So here, before we call the function, we have a global variable A that points to a list which has one element, which is this 3. Now we call the function x element to 5, and exactly the same as here. Python creates a new local scope for this function x element to 5. In this local scope, we create a new variable x, which is here at this point. We ask Python to create a new local variable that's called x, and then we make it point at this position. We make x point to the same object that A is pointing to. So now x points to this list. So in a way, exactly the same thing happened here and here, right? In both cases, x points to the same object that A pointed to, and we don't create a copy of that object. Only here the object is a list, and here the object is an integer. And now inside the function, different things happen. So now if we look at this line inside the function, what happens here is very different. So in the first case, we say x equals 5. So what we say is that variable x should now point to a different object, a completely new object that is a 5. So we create a new object 5. And x now doesn't point to this object anymore, but it does point to this new object. And here, we don't make x point to a different object. So in the other function, we don't say x equals 5. So we don't change the object that x points to. X still points to the same object. But what we do, it looks a bit similar because the symbols are similar. But what happens is very different. We don't change what x points to. With these brackets, we jump into the object x and we change the object. So we don't change this green arrow. This green arrow stays the same. But we go into the list and we change what the zeroth element points to. So here we say that the zeroth element should now point to 5. And this gets deleted. So in both processes, no copies of any objects are created, right? It's just that in this case, we change the reference. And in this case, we change the object that the reference points to. For whom is this clear? Okay. I think the trick is to play a bit around with that and draw the diagrams to get some practice on that. So this here, it's generally called, it's a procedure. And it's a procedure because it has some side effects. So let me show you what a function is, and then I can contrast that with the procedure, what the procedure is. But this thing here, generally we call a side effect. Which means that if you call this x element to 5, then it has some side effect in that it changes this global variable, this object here, this global object. In contrast, you can instead work without side effects. In contrast, you can have a function that gives you a return value without any side effects. Maybe you can do it like this. A is 3, def get list with 5, return 5. And then you would call it in this way, A equals get list with 5, print A. So here we can draw a third diagram. What happens in this case, I think this case is much easier to understand, I hope. So we have our references, we have the objects, we have a global variable A that points to a list. And the list element is 3. So this is the situation before we call the function. Then we call the function. What Python does, it creates this local scope. The local scope doesn't contain any variables in this case. I mean, there's no parameters to the function, and here we don't create any local variables. And instead, what the function does, it creates a new list. So the function creates a new list with one element, which is C5. And then it returns this list to the caller. So it says return this list. And then in the code, if you look at this part, here we say that A should be equal to whatever gets returned by this function. So now we return this list, and then we say A should point to this new list. So A doesn't point to this anymore. A points to this, and the local scope gets deleted. And this doesn't have any side effect. And this is what we call a function, because it doesn't have any side effect. So if it doesn't have a side effect, it's a pure function. Who understood the difference between this and this? Okay. So this is what we call a function. And this is what we call a procedure. The function returns a value, has no side effects, and the procedure has side effects but doesn't return a value. Maybe I can give you more examples. So let's say we have a list of characters. A, B, C, and now we want to append a character to that. Then there's two ways we can do it. The first way is we can do it like this. Or maybe let's start with this one. We can do it like this. We can create a procedure. We say def append A of some with one local variable x, or one parameter x. And then we say x dot append. Probably we always want to append an A. And the way we call that would be to append A of L, print L. So what this code did is it took the list L. At this point, we call the function append A, and we assign the parameter x the same object that this global variable L points to, which is this list. And then for this list, we call dot append A. So this is a append by side effect. Okay. Who understood how this code works? Okay. Then let's try to do it with a function, with a pure function. Def append A x. I will leave this open, and I want to call this, and I want to say L equals append A of L. Print L. Does anybody have an idea of how we could do this without any side effects? So definitely we want to say return something. First we want to do something, and then we want to return that. And we don't want to change the x. Or maybe I can assign that to a new. Let's say afterwards I want to have m, which is the appended list, and I still want to have my unchanged list L. So append A should not change L. It should give me a new list, M, that is like L, but it has A appended. Yes?
You could type return x dot append A.
Let's try that. Oh, now that's not quite what we wanted. Now L has A appended, and M is none. So it didn't quite do what we wanted to do. Does anybody have an yes?
We can do return x plus list row contains A.
Return x plus, like this. That works. Let me go back to the previous. So x dot append A. This didn't work because this append is a procedure. It changes x, and then it doesn't have any return value. It returns none. So because append returns none, then our function append A also returns none. Right? So m afterwards is none here. M gets assigned none because append A returns none, and x got changed. X got changed along the way. So L got changed along the way. Maybe I just write different versions of this. So this doesn't work. This does work. And the reason is that this plus operator, it creates a copy of the list x, right? It creates a new list. Another thing that we could do is we could create a copy of x explicitly. We could say temp equals x dot copy. We copy x. And then we say temp append A, and we return temp. So what this did, who wants me to draw a diagram of that last version? To draw this image? Okay. You can do it for yourself if you want. So what this did is at this point we call the function append A. Then here we make the variable x point to the same object that L points to. So x now points to that list here. Then we make a copy of that list. Now we have two lists. We change the new list, which we assign to the variable temp by appending A, and then we return this new list. These versions are nice and okay. Maybe we could quickly discuss the benefits and drawbacks of the two versions. So here we had the this one was a procedure. And maybe I think this one is a bit more explicit. This one is a function. Can somebody explain some, or come up with some benefits or drawbacks with implementing this as a procedure versus a function? What's the benefit of doing a function? So you don't change the arguments, you just, you make sure you don't change the arguments, you just create a return value, yes? Yeah. The list L doesn't get destroyed, right? It doesn't get modified. And in general, for me, it's much easier to understand. So I have a function, I put something into the function and I get some result, but the stuff that I put into the function doesn't get changed. So for me, it's cleaner and it's easier to understand it. And it's, in general, I think it will be easier to find bugs in your program. And if you have a lot of procedures which change the arguments, you have to be a bit more careful. There are some programming languages which argue for using only functions, like Lisp and Scheme and so on. This is called functional programming. And they say, oh, it's much cleaner to do it this way. Can anybody come up with an idea why procedures might also, or whether procedures also have a benefit of, if you don't work with a return value, but you change the arguments of the function, yes?
If you want to process something over and over again, it develops and changes something like dynamic systems, for example.
Yeah.
Because procedures make far more sense.
Why?
Well, because if you have an initial state and you just do not change that state and you run for only functions, then for the, I don't know, 5th iteration, you would have to run the function 5 times, whereas you would have to, and you would not really get the intermediate values. While in the procedure you would have each intermediate value in each iteration.
You keep the history, basically, right?
Yeah.
If you're using a,
And also
no,
easier to
you-
start,
if you-
it's rather
you don't
like,
keep, yeah.
if you are in year 5, let's say, then you only have to take the inputs of year 4, which are already there, because they were changed along the way. If you do that with functions, you would have to run again from 1 up to point.
Yeah, but you can store the result of the previous year and then run a function on that.
Okay.
Yeah. But I think you have a point, and the main point, can anybody look at this code here? I think it's most clear in this code. What happens if the list is 5 gigabytes in size?
You need a quarter of your memory because you now have 2 5 gigabytes.
Yeah. You have to copy your 5 gigabyte list, right? So if you have really big data sets, this copy is the problem, this here. And there's a copy here, which it's just hidden from you. The copy here is in this plus, right? So if you're working with really big objects that need a lot of memory, then procedures have the benefit that they don't need to copy the data. You just work. It's also called they work in place. So they change the existing object. They work in the place of the existing object. And in the next lectures, when we talk about working with big data sets and NumPy and so on, you will see that NumPy, numeric Python, and a lot of the numeric routines work almost exclusively with procedures. So they work in the memory and they try to avoid creating copies of your data whenever they can. Because if you create a copy of a 5 gigabyte object, well, your user will not be happy, right? Especially if you don't really need that copy. Okay, so functions, in my opinion, my personal opinion is that functions are much cleaner and it's easier to debug and it's easier to understand what's going on because you don't have any side effects. But procedures can have huge benefits in terms of performance because they don't need to copy the data if you're working with lists and big data sets. You might do something. Let's do Let's do a stupid version of this. Let's start from this one. I didn't want to start from that one. I wanted to start from this one. This one. Oh, basically, it's already here. Okay, this didn't work. Let's fix that version. And let's say x append a, return x. This fixes this code. Does anybody have an opinion about this code? Yes?
Why did we create M in the first place if it's basically the same as L?
Yeah, M is the same as, it's exactly the same object as L. So this tries to do both, to be both a function and a procedure at the same time. So it changes the argument, and it also gives you a return value. And I find this super confusing, so I recommend you never to do this, because if people get a return value, they will not expect you to change the arguments. And if you change the arguments, they will not expect to get a return value. So I think you should decide for either changing the arguments or giving a return value, but not do both, because you will confuse everybody. And function at the same time. That's very confusing. So I recommend you never to do something like this, but there's something worse that you can do. So the worst thing that you could do is a version of this. So you don't take any parameters, and you directly say x append a. And you don't return anything. Okay. So the first question is, what does this do? Yes.
Nothing.
Why do you think it does nothing?
No, I mean L and A, wouldn't that be locally?
Yeah, but there's no local variable L. Let's draw a diagram for that. Let's draw a small diagram. So we create a global variable L that points to this object with this list. These point to some letters. L points here. Then we call append A, we get our local scope. Our local scope doesn't contain any variables, because we have no parameters here, and we don't create a local variable here. We don't say L equals or something, right? So now we refer to L here. What does Python do? We refer to L from inside the function. What does Python do now? Yeah, it searches inside the local scope for a variable named L. It doesn't find it. It goes to the global scope. There it finds a variable that's called L. It follows that link, and then it changes this list, the object that L points to. So let's run this. It works perfectly. Yes. Why is this a problem? Can anybody imagine why this is like the worst thing you could ever do? Yes?
Because it only works if your list is called L. If you rename it, it just doesn't give you anything.
Yeah, exactly. So you hard code the variable name L inside your function. And if your friend comes and he copy pastes your function without understanding what it does, and he copies it into their own code, and they don't have their own variable L, the global variable L, then your copied code will not work, and nobody will understand why. Plus, if you have like a 5,000 lines long program, and you have a global variable L, and then you refer to that variable from some function deep in your program, and at some point you want to rename your variable L to something else, then your code will be broken, right? So it's very intransparent for everybody. So at the position, when you actually call the function, at this position, right, you have no clue what's going on. So at this position, you don't see any parameters, you don't see any return values. The function does something magical. It works on some global variable, but I generally recommend you not to do this. There might be some exceptions, but in general, don't do it. Don't do this. Okay. I think that was what I wanted to say for procedures and functions. Are there any questions?
I do have a question. I'm using PyCharm,
Mm-hmm.
and if I try and type in this function, it doesn't actually do anything.
If you do this here,
Yeah. If you want to look.
yeah, maybe after the lecture.
Okay.
Yeah. Yeah. Don't do it anyway, so. Okay, now, has anybody of you programmed in some programming language such as C, C++, Java? Who has programmed in that? Okay. So I think anybody who has programmed in a programming language like this is used to typing. So in C, if you have a variable x, you cannot say that this is x, right? You have to say whether it's an integer or whether it's a float or whether it's a string or something. And if it's an integer, then you cannot just go ahead and assign a string to it like you can in Python. This is called a strongly typed language. And in Python, we have a concept that it's called duck typing. And duck typing really refers to the bird, duck, yeah, the thing that quacks and walks. And the philosophy of Python is if it quacks like a duck and it walks like a duck, I don't care what it is, for me it's a duck. So if it quacks and walks like a duck, it is a duck. So basically, Python doesn't care at all what your objects are. It only cares what they can do. So if it quacks and walks, you can treat it as a duck, even if it's, I don't know, even if it's a student in the Mensa or something. And the nice thing, so this gives you a very different philosophy to, who has heard of polymorphism? So the idea of polymorphism is that you can write a function that can work on different kinds of objects. And in Python, all functions are polymorphic, basically. So if you write a function, def plus xy, return x plus y, maybe you were thinking of integers. Maybe you wrote this code and you were thinking of a function that can work on integers. But you didn't say that x and y have to be integers, right? You're not even allowed in Python to say something like this. So in C, you would say something like this. And you would say x and y have to be integers. If x and y are not integers, my program crashes. In Python, you're not allowed to do that. And the question is why. So now you can use your function with integers, 3 plus 4. It works. But what you can now do in Python, you wrote this program, you were only thinking of integers, and now some different person comes along, copies your code from the internet or somewhere where you uploaded it, and they do this. Oh, no, I wanted to say, sorry. I wanted to say this. And they do this. And while you wrote the program, you were never thinking about anybody. Maybe you didn't even know about floats. And you didn't even think that somebody could ever do something like this. And your code just works. And then a different person comes along, and they do this. And your code just works. And then even a different person comes along, and they do this. And your code still works, right? So the idea behind duck typing is all these guys here, they quack and walk like ducks. So integers, floats, strings, and lists, which means that you can apply this plus operator to them. And as long as you can apply the plus operator to the objects, then your code will work for this kind of objects. And this makes Python really powerful in the way that you can write some code, and your code can afterwards be used in some ways that you never intended when you wrote the code. Maybe we have time for a different example. Maybe you write a different function. It's an intersection. Maybe you think about intersection of lists. Def intersection of two lists. Maybe think about list 1 and list 2. Then your result is the empty list first, and then 4 element in list 1. If element is in list 2, result append this element, and in the end I return the result. Okay. And when you wrote this function, you were thinking of lists. So you were thinking about intersection of 1, 2, 3, and 2, 3, 4. Okay, this computes the intersection of the list. But now, a different person comes along, and they do this. They call your function, they call your function with tuples instead of lists. Your code still works. And now still a different person comes along. And they call your function with strings. Your code still works. And now a different function person comes along, and they do this. What happens if somebody does this? Yes?
I want to guess, is either binary?
Yeah, that doesn't work on the binary representation. That was nice. You get an exception. It says that the object is not iterable. So basically Python complains that 5 and 3 don't quack and walk like a duck, right? So they are not iterable. So you cannot do 4e. I think the position where you get this exception is this: 4e in 5, but you cannot iterate over the number 5, right? So the lesson is, in Python, you should generally never do any type checking on your variables of your functions. You just should work on the objects that you get, and if they quack and walk, you should be fine. You should just continue working with them. And if these objects don't quack and walk like ducks, then Python will take care of this for you. So Python will raise this exception here, and it will complain to the user that they cannot use your function with these. But you, as a programmer, you don't have to take care of this, right? Okay. Then the main point of functions is that we can reuse them, and the best thing about reuse is to use functions that somebody else implemented for us. That's the most convenient thing, right? You find something, somebody else implemented it for you, and you just use it. And if you find something that somebody else implemented for you, you have to import it. And who has already imported some libraries? Okay, there are different ways that you can do it. You can do this, import math. And then afterwards, after this, you have to say math dot, and then you can call the function. You have to say which library or which module the function that you want to use is in. So you can compute 19 factorial. There's a different way from math import factorial. And if you do this, then you can just say factorial 19. Does anybody have an opinion which of these is better in what situations? Yes?
Maybe the first one you automatically go for the whole script, and the second one is just for a limited scope.
Yeah. The first one imports the whole script. Yeah. But the benefit of the first one is that if you have a function in your own program that's also called factorial, then the first one doesn't conflict with that, because you always have to say math.factorial. So it's clear that you refer to the factorial function that another person implemented for you that implemented this math module. If you do this, then you have to be very careful that you don't have a function in your own code that has the same name, right? So it's more vulnerable to name clashes. There are some lazy people who do this from math import star. And I generally recommend you never to do this, because you don't know what functions are defined in math. And there might be some functions defined in math which conflict with your own functions, and you will have a bug which will be very difficult for you to find. So in general, if you don't use the function very often, I would always recommend this. Because you only have to type math dot a few times, and it's much cleaner, and you don't get any name conflicts. If you use factorial, or you use this function all the time, like, I don't know, hundreds of times, then this might be quite annoying to always write math dot. So you can do this, but you have to be careful. And in general, I would recommend you never to use this. There's another thing that you could do to be a bit more convenient than this, but not, it still avoids the name conflicts. And you can do this, import NumPy. So you could do import NumPy, and then afterwards, you always have to write, if you want to create a matrix, you would have to write numpy.array. 2, 3, 4. This is a bit inconvenient, so you can make it a bit more convenient to say import numpy as np, and you can give a shorthand. So it's just to give a shorthand for s. Yeah, that's right. So I think I always try to use this. So this is the thing that I try to use most of the time. Except I use the function over and over again, then I might use this for like selected functions that I use very often. There's a small pitfall that I wanted to show you. Let's do a backup. Pitfall. What will happen in this case? Maybe we can draw a small diagram. So the problem is that print is a reference like all the other references. So you have a reference that's called print in your global scope, and it points to some special object, which is the print function. And if you say print bracket something, then you follow this reference, you go to this function, and you call this function. Now what we did is we assigned the reference print a new object, 5. So what will Python do if we now say print hello world? It will try to call the object 5 as a function with the argument hello world. And of course that doesn't work, right? Because 5 is a number, it's not a function. So it gives us a type error, and it says that int object is not callable. So basically a number is not a function. And this might sometimes happen when you're programming, that you overwrite some existing, like pre-assigned reference names, and then you get a bug like this. So whenever you see something like this, then somewhere above you did something like this, right? So this just happens sometimes during programming, yes?
But doesn't the font and the color of the text already suggest that this is already reserved?
Yeah, if you use the Jupyter Lab or Jupyter Notebook, it does. But if you're programming in some text editor, it doesn't. Yeah. But when you see some green color, if you write this and the print shows up as green, you should immediately think, maybe I shouldn't do this, right? And instead, we can now do this. We can now say backup hello world. That works. So the variable backup now points to the function that can print stuff. And we can also say print is backup. And now we repaired the situation. Okay, so this is basically everything that I wanted to say about functions. Are there some more questions about functions? Okay, then we will proceed to... Yes?
Sorry. I
Yeah, yeah. I think that's my opinion. That's my personal opinion. Yeah. Okay. Then new notebook. Okay. Then who of you has ever written a program that didn't work as you intended? Okay, so I think that's the natural experience during programming, is that you write programs and the programs don't do what you want them to do. And in general, I think, so there's a joke among programmers that say that writing code takes up 90% of your time, and debugging the code takes up the other 90% of your time. There's also some people who say that debugging your code takes up 100% of your time. So all programming is debugging, because you start with the empty program and it doesn't work. And then you have to start debugging. Right. But generally, you will spend most of your time doing... who thinks that they spend more than 50% of their time debugging? Okay, I think that's a natural situation, that you spend some time writing code and then you spend a lot of time for debugging. That's not your personal problem. That's a problem for everybody, right? It's just how things are. And I want to show you a few tools for debugging that will hopefully help you a lot during the exercises and during your programming life. So we only have 30 minutes left. So what I will do is I will first show you the stuff that you need for the exercises. And then I will go back and show you stuff in more detail. So who has used a print for finding out what your program does? So you write some program, it does some strange things. You print out the content of some variable. Okay. You should not do this anymore. Does anybody see what's the problem of using print for getting the states of internal variables? What's the downside of using print? You forget to remove it. Yes. Afterwards, you ship your program to your customers, and your program prints a lot of stuff. And your customers wonder what all these prints mean. And I think the first problem is that you have to remove them at all, right? So you spend a lot of time creating your prints, and then afterwards you spend a lot of time removing them again. And then you find another bug, you put all the prints back in, and then you fix that bug, you remove all the prints, and then you find another bug, you put all your, so that doesn't sound very useful. So what would be nice would be a kind of print that you can switch on and off with a flag. And it would be nice if this print also would, if you could make this print write to a file instead of to the console. Because if you're writing some server, for example, you're writing a web server or something, and the server is just running, then you want all the prints to go into some file. So once in a month, you can go to your file and look at all the things that happened. And this is called logging. And this is really nothing more than a print, just that you can switch it on and off, and you can direct it to a file. There's a Python module that's called logging. So you just say import logging. And afterwards, we will say, so every time we want to log something, we will say, logging.debug, whatever. And this is one of the cases where I'm too annoyed to always write logging.debug. So in this case, I will also say from logging import debug. So now from now on, I don't have to write this logging.debug, but I can just write debug. And then we also have to set the log level. And this is something that you just have to copy and paste. So you have to get the logging, the logger, logging.getLogger, and then you have to say logger.setLevel. And setLevel basically says, do you want to see the messages, or do you want to switch it on and off, basically? But now we want to switch it on. So we want to set the level to debug. And then we can create messages just by this. Debug.start, and then you get a message like this. Which basically says it's debug level, it happened at the root of your program, and the message was start. And then afterwards you can switch it on and off. I think that's basically all there is to logging. And if you want to disable it, you can just say logging.disable. That's it. And you don't have to remove all your prints. You just say logging.disable, and that disables your logging. Okay, now that is the short overview of logging. Then there's another tool, which you already saw a lot. If you compute this, 3 divided by 0, what will happen is this. Python gives you a 0 division error, division by 0, because you're not allowed to divide by 0. And what will happen is your program crashes. Whenever you do this, you get this exception, your program crashes. But in some cases, you don't want your program to crash, right? You divide it by 0, you want to fix this, you didn't really want to do this, and then you want to fix the situation, but you don't want your program to crash. And if you want to continue, after you got this problem, you have to do this. Yeah, this is an exception, and you have to catch this exception. You have to say, okay, I will try to do this. I will try to divide by 0. And maybe it works, maybe it doesn't work. And if it doesn't work, then I want to say print oops. But then I don't want my program to crash. Right? You can also raise an exception yourself. Def maybe you have your own print with some string s, and maybe your maybe you don't want to print the empty string. So if s equals the empty string, then you want to raise an exception because somehow you don't want to print empty strings. Raise I think it's called like this. I don't like to print empty strings. Else, just print this. And now if you call this my print with the empty string, then you get this exception. Right. Yes?
Can you create more exceptions?
So in the moment that you create the exception, you mean create multiple exceptions at the same time? In the moment that you create this exception, your program crashes. So afterwards, you don't have time to go to create a second exception, except somebody somebody catches this exception. So in general, your exception is in the moment that you raise an exception, you create an extraordinary situation, and generally you can only raise one exception at a time. So now, if somebody wants to deal with this, they can do this try my print empty string except print, oops, sorry. They create this. So what now happens, you call myPrint with the empty string. MyPrint goes into this if clause. It raises an exception. Then from this position, the control, so the exception propagates, and it gets caught here. And here I go into this. I say, oops, sorry. There's a variant. So quite often I say, if something is true, I want to raise an exception. So there's a shortcut, and that's called assert. For example, we want to calculate the square root of x, and we want to make sure that x is always positive. And then what we say here is we assert x bigger 0, and otherwise we say cannot deal with negative numbers. So we first make sure that x is positive, and then we return x to the power of 0.5. And now if we calculate the square root of 9, that's 3. And if we calculate the square root of negative 1, we get this assertion error, cannot deal with negative numbers. So these assertions are really a nice debugging tool. They are mostly useful for you during debugging your program, so that you can make sure that some things that assume should always hold, that they actually always hold, and if they don't, if somehow these assertions are violated, your program should crash, right? And you should get some notification. For example, if you're programming a system that controls traffic lights, and you have multiple traffic lights at the intersection, you could add an assertion that one of the traffic lights from both directions should always be red, right? If both are green at the same time, your program should crash. And you should find these problems before actually delivering your product. Okay, so I think this was the short overview. Are there some questions about logging, exceptions, or assertions? Yes?
If you use a try function, for example, try divided by 1,
Mm-hmm.
there's an exception couldn't occur. So what would you return? Just return.
Oh, so if there's no exception here, yeah, if there's no exception, nothing happens. If there's an exception, there's no return value. It jumps immediately to the except. So as soon as this exception occurs, your program jumps immediately here. So whatever else happens in here never gets executed. So it's really a jump to this position in the code from wherever you are. So you can be very deep in your code. There's an exception very deep in your code, and you immediately jump to where you catch the exception. Yes?
You earlier said it would be useful to save all your debug logs in a file. Does it do it automatically, or do you need to?
No, so if you want to save it to a file, I actually don't know, so we have to look it up. You have to look it up in the documentation of logging, how to save the log to a file. I think it's not difficult, I just don't know how to do it. And this is really mostly not for if you're programming in the Jupyter notebook here, then really you want to have all the output probably in the notebook. But if you later you write a program that you put on some server, or that's just a program that you want to run, then you probably want to save the debug stuff to a file. Okay, So now let's go back to. So let's remember that we set up the debugger up here. So now we can use debug, and let's start with examples. Let's start with a simple example. Maybe you want to. Does everybody know what the factorial of a number is? So 3 factorial is 3 times 2 times 1. So let's write a function that can compute that. Def factorial of n. So the result first should be 1. Let's start. So the idea is that we start with the 1 and then we just multiply with all these numbers to get the factorial. So the result in the beginning should be 1. And then we say for I in range n plus 1. So let's remember that a range goes up to the number, excluding the number that we give it, right? Then we multiply the result with I, and then we return result. Okay. Now let's compute the factorial of 25. 0. There might be a problem. Factorial of 3. 0. Okay. I think it should be 6. So there's a bug somewhere. So let's see how we can debug this. So one idea would be to go into this for loop and to get the values of the variables I and result at every iteration of the for loop. So what I would do is I would go here. I would say debug I is I and res is res. Okay. And let's go here. Okay. So it's the first iteration. I is 0 and res is 1. And then I is 1 and res is 0. And then I is 2 and res is 0. And then I is 3 and res is 0. Does anybody see the bug? Yes?
With range, we start at 0. So
Yeah.
I is 0, we multiply rest by 0, and then rest is 0, so it doesn't matter what we multiply rest with, it's 0.
Yeah, range starts at 0. So in the first iteration, so in the for I in range, in the first iteration here, I is 0, and then we multiply res with 0, and from then on, res will always stay 0 because we multiplied it with 0. So let's fix this. Let's just start at 1. Now it works. So the technique for debugging is just to go into your code and give you the values of your variables, and this might help you to find the bug. There are more advanced tools for debugging which are called debuggers. And what debuggers allow you to do is to set breakpoints, to set positions in your code where the execution will stop. And at that point, you can inspect the values of all the variables, and you can also step one by one through your code. Most people I know very rarely use debuggers. So most people I know work with debug messages. If you're writing some complex program, you might want to use. Has anybody here ever used a debugger? Okay. Okay. If you have some complex code, you might want to use a debugger. But if you have some simple code, you can work with debug messages, I think. Is there anybody who prefers a debugger over debug messages? Okay. Yeah. Okay. Everybody who has used the debugger doesn't actually prefer them. That's an indication. Okay, now we have found the bug. Now that we have found the bug, we can disable logging. We just say logging disable. And now if we compute factorials, we don't get the debug messages anymore. If we want to enable logging again, we have to say logging.disable, and then we have to say the level, logging not set. I would prefer logging.enable, but that doesn't exist. You have to type this. So with this, you can switch your logging on and off. Okay, let me start with another program which has a number of bugs, and we will probably not finish this. So if you want, you can try to find the bugs during the week. So who knows what a palindrome is? What can you explain what it is?
The word or a sentence that you can read from both sides.
Yeah. It's a sentence that you can read forward and backwards, and it's exactly the same sentence. I think one example is from Napoleon. Able was I ere I saw Elba. There are funny examples. I think you can find a lot of examples online. So basically, anybody remembers this band? That would be in palindrome. Or Anna. So depending on, irrespective of whether you read it forward or backward, it's still the same word. Okay, let's write a function that checks whether a string is or a list of letters is a palindrome. So X should be a list. Return true if X is a palindrome, false, or else false. So the idea is that we take the list, we revert it, and then we check whether it's still the same list. So we say temp is X, then we say temp dot reverse, and then if temp equals X, return true, else return false. Okay, and then we need a second function to ask the user for letters. Def checkpal maybe. So first we want to ask the user for a number of letters. For I in range n, we first have an empty list. Result is the empty list. Then we ask the user for a letter. Elem is input, enter letter. Result append elem. And now we check whether it's a palindrome. If ispal result print is a palindrome else print is not a palindrome. Okay, now let's check ABBA maybe. Check pal for letters. A, oops, B, A, that was not what I intended. Oh, so yeah. So that maybe I see the problem here immediately. So we want to have this at this indentation level. Okay. So if you can see the bug just by eyeballing it, that's of course good. Maybe you can't. But we fixed this bug. Oops. We should rerun this, I guess. Oh, okay, now my seems like there's a problem with the what's the problem? Oh, there's a problem here, yeah. But now I have the first problem that, oh, now it works, okay. A, B, B, A is a palindrome. Okay, that's okay. Then let's check a non-palindrome. Check pal for, oops, A, B, C, D. Oh, A, B, C, D is also a palindrome. Wow. Yes?
Shouldn't it, in the function isPaul, shouldn't it be temp equals x.copy?
Oh yes, now people find all kinds of bugs just by eyeballing it. That's of course good. So one solution is you go to the lecture, you ask 100 people, you show them the code, and each of them finds one bug. If you have 100 people, that's of course good. But maybe we want to proceed a bit more fundamentally, adding. So the first thing that I would do, so the code doesn't work, right? The code always says is a palindrome, even if the entered stuff is not a palindrome. So the first thing I would do is I would try to find the minimal input that creates a problem. So let's do check pal 1. One letter would be good. The problem is if it's one letter, it's always a palindrome, right? So we cannot test it on input with only one letter. It has to be at least 2 letters. Check pal 2. So A, B. Okay. Now we found a minimal input that creates a problem. Let's work with that input. And now what I would do is I would jump somewhere in the middle of the code and try to add a debug message there. So I think one good position to check maybe could be here. Debug. Here result is result. Okay, so now here in the middle of the code we look at result at every iteration of the for loop. So let's do check pal of 2 with our minimal input. Okay, at the first iteration, result is the empty list, and at the second iteration is the empty list. I think one person already noticed this bug by eyeballing it. Can anybody else see the bug? Yes?
There are now 2 bugs. One bug for the debugging, because the debugging is 1 line too early.
Uh-huh.
And the original bug is that result is within the for loop. So with every iteration, the result will be empty.
Yeah. So at every iteration of the for loop, the result will be overwritten with the empty list. Let's fix that. And you also prefer to have the debug. Let's fix that. So where do you want the result to be? One line before the for loop. And then you also prefer the debug to be here. Okay. Okay, so this is the state up to now. Maybe you can check if you want whether this now works or whether there are any bugs left. And I think it's a good code to practice your debugging skills. As a note of caution, there's not only one bug. There's a number of bugs in this code. Like in any realistic program, there's not one bug. There's dozens or hundreds of bugs in every program. Okay, thank you. See you next week.